A corporate budget is how an organization communicates its operational and strategic objectives. It quantifies the exact operational steps required to achieve a massive goal. To monitor progress toward these objectives, companies rely on performance evaluation systems. But the information sent up the chain to top management arrives highly aggregated and often with a time delay. These executives are responsible for the organization's overall financial results and long-term prospects, but the summarized data they review obscures the day-to-day realities playing out on the factory floor. Down at the operational level, managers require a completely different view. Their reports are built on raw quantitative inputs, like labor hours, machine usage, and daily production data. Evaluating operational performance through a single top-level budget surplus or shortfall creates a mathematical blind spot. It hides the specific mechanics driving the financial results. The starting point for any performance evaluation is the static budget variance. This is the total variance that management must explain. At its core, a variance is simply the mathematical difference between the amounts initially budgeted and the amounts actually incurred or earned. We categorize these differences based strictly on how they affect the bottom line. A variance that increases income is labeled favorable, with an F. A variance that decreases income is unfavorable, marked with a U. Look at the top row of this model. The static budget maps out expectations, while actual results show what happened. Comparing these two directly blends market-driven volume changes with true operational efficiency. We have to systematically deconstruct the static variance. Breaking this figure down into its constituent parts allows managers to isolate specific factors, like production volume or input pricing, that are otherwise buried in the aggregate total. The main failure of the static budget is that it assumes production volume will remain exactly as planned. If demand spikes and actual production significantly exceeds expectations, the company will naturally consume more materials and labor. A static budget compares these higher raw costs against the lower initial forecast, triggering an unfavorable reading that fails to account for the increased output. The mechanism that solves this scaling problem is the flexible budget, positioned here in the center of our model. It calculates the standard inputs allowed for the actual output, multiplied by the standard price. It adjusts the baseline by asking a strict hypothetical question. Given the actual number of units we produced, what should our costs have been? To calculate this accurately, we must observe strict cost behavior rules. Note the formula logic here. Variable costs are isolated from fixed costs. Variable costs are stated per unit so they can scale fluidly with actual output. Fixed costs, however, are incurred regardless of activity levels, so they remain strictly stated as total sums. Adjusting the mathematical cost baseline to match the reality of actual output isolates the true performance of the operations team. It ensures they are evaluated on how efficiently they built the product, rather than how many products the sales team managed to sell. With the flexible budget in place, the total static budget variance drops down and breaks into two primary branches. On the right side, we bridge the static budget and the flexible budget to find the sales volume variance. This isolates the impact of selling more or fewer units than expected. It operates under the assumption that selling prices and production costs remained perfectly constant. On the left side, we bridge the actual results and the flexible budget to calculate the flexible budget variance. This side captures the true operational deviations. It measures changes in actual selling prices, the costs of inputs, and the quantities of those inputs consumed. If a company manufactures multiple products, the sales volume variance on the right can be further divided into sales mix and sales yield variances. This primary mathematical split is the crucial dividing line.
It separates market-driven demand variations from factory-driven efficiency problems. To find root causes on the factory floor, we must unpack the flexible budget variance into its specific direct inputs, materials and labor. Direct materials branch out into two metrics. The price variance isolates the difference between what the purchasing department paid per unit of raw material versus the standard price. The quantity, or usage variance, measures how efficiently the factory floor consumed those materials. When a product relies on multiple raw materials, the usage variance splinters even further into materials mix and materials yield variances. Direct labor follows a similar structure. The rate variance measures the difference between hourly wages paid and the standard rate, while the efficiency variance calculates the difference between actual hours worked and standard hours allowed. And just like materials, varying labor rates require calculating labor mix and labor yield variances. Consider a standard requiring a worker to complete 1 unit per hour at $6 an hour. If the actual costs come in at $6.88 per unit, the actual cost exceeds the standard cost, resulting in an unfavorable variance of 88 cents per unit. Isolating price and wage rates from actual usage and efficiency allows management to pinpoint departmental accountability. It separates the economic decisions made by the purchasing department from the physical execution happening on the production floor. The final, and arguably the most complex, component of the entire operational variance tree is the factory overhead. Overhead requires a unique four-way analysis because, unlike direct materials or direct labor, it contains a blend of variable and fixed costs. The variable overhead is split into the spending variance and the efficiency variance. The fixed overhead is then split into the spending or budget variance and the production volume variance. Rigorously deconstructing these indirect costs is the only way managers can exert control over processes that would otherwise quietly erode profit margins. Calculating this complex hierarchy of data is only the mechanical step. The value lies in how managers actually utilize the results. Look at this scenario, where a controller holds meetings solely for departments with a 10% unfavorable variance. This is the core operational philosophy enabled by variance analysis. Management by exception. Executive attention is finite. This practice protects it by ignoring operations performing within expected limits, focusing time and energy solely on significant deviations. When investigating these deviations, responsibility must be assigned logically. Performance measures should be tied directly to the specific cost and revenue drivers a manager actually controls and has the information to fix. The entire mathematical architecture of variances serves this single purpose. It filters out operational noise to highlight actionable exceptions. There is a pervasive misconception that variance tracking is a punitive tool designed by corporate controllers to assess blame. As we see here, that is explicitly incorrect. Standard costs are defined as engineered targets. Unlike simple historical budget estimates, they exclude existing inefficiencies and focus on current performance potential. If a department shows persistent unfavorable variances, it does not automatically mean employees are failing. Often, it indicates that the standards themselves are outdated and require reevaluation. The ultimate purpose of computing variances within a performance monitoring system is to trigger organizational learning and constructive solutions. The framework does have limitations. It is inherently backward-looking, focusing on past events, and the time it takes to identify a problem may delay corrective action. Even with these constraints, a rigorously deconstructed variance analysis system provides the specific data required to trigger organizational learning and track continuous improvement over time.